In these slides, we want to illustrate the idea of circular motion, a charged particle and a magnetic field. So to remember, the force on a charged particle is QV cross B. V is the velocity of the charge, Q is the charge, and the magnetic field is B. So we showed that the magnetic force acts perpendicular to both V and B. And we showed, remember, that there's no work that's done on a charge by the magnetic force only. So the speed always stays the same, but because the speed stays the same, it doesn't mean that the direction can't change. So the direction can change, keeping the same speed. So let's take this case where you have a magnetic field into the page illustrated by these crosses. You have a positive charge that's initially moving to the right with a velocity v. What direction would the force be on this charge at this point in time? If you do the cross product between v and b, v cross b, you put your fingers in the direction of v, you curl towards the magnetic field into the page, the direction of the cross product will be in the upward direction. Since the charge is positive, then the force will be in the upward direction. So what will happen to this charged particle? It's moving with a velocity v, but it's experiencing a force upwards, so it will start to deviate upwards, like that. And when the charge reaches this position, it will be moving upwards with a velocity v. And now in this position, what would the force be? So again, apply v cross b. V cross b, put your finger in the direction of v and curl towards b. The cross product will be to the left, and the charge is positive, so the force will be to the left. So the force will be to the left. What will this force do when the velocity is upwards? It will try to make the charge curve this way. In the end, it will turn out that the charge will move on a circular path. As the charge is moving on a circular path, the speed stays the same always. We said that the magnetic field can't change the speed of the charge, but it can change the direction. So the velocity vector changes, but the speed doesn't change. And if you have a positive charge and a negative charge in the magnetic field moving with the same velocity, we've shown before this issue, and you can remember again by getting the force on the charges. Because the force on the negative charge, you have a Q that's negative, so when you multiply V cross B by a negative value, the force vector is opposite the force vector for a positive charge. So this charge will move in a circle this way, and this charge will move in a circle this way.